all the qualifications aside, I am basically a teacher. Yeah. It's okay. Yeah. Agrarian, thank you very much. Firstly, I want to share with you. Anantapur Engineering College has one advantage. They can summon me anytime, and I will be available to you. Call me anytime, and here to serve your need. All qualifications aside, I take one simple qualification which I would like to share with you. I am a teacher. So therefore, during the course of my discussion with you, I am sure there will be a lot of things which you need to know, which you might like to ask me, ask unhesitatingly. And here to, I think by and large I will be able to explain and sort out a lot of technology aspects. And I want to share with you the background. I have an hour and a half to finish completely, an hour plus an hour and a half. Check again. I have an hour and a half to finish everything. Okay. In between, we will have at a suitable time, we will have 5 minutes break, 5 minutes break, because it is not advisable to continuously keep talking.
Discussion can be there. Once you give a break.
Once we give a break, then we will continue again. There are Tech 1 and Tech 2. And once I finish Tech 1, I'll give a break. Then we'll have Tech 2. And between we can have some question and answer session. But before you ask, I recommend that formulate your question in your mind so that you are clear to ask me and I will be clear to explain to you. Let me give you the background. Are you able to see me? I think we can push it a little more. Are you able to see? Okay. I can actually stand. The background is Professor Shankar Garu wrote to me. He sent a small message that will you be able to support us with some kind of a project initiative which can get into some agrarian application, that means agricultural infrastructure. Then he also hinted to me that Anantapur Engineering College will be very keen to undertake that, and they would be in a position to look for some kind of a fund and grant. And he mentioned to me about APC at that time. And so once we have the grant, we will be able to have a combined initiative, and we will be able to produce some kind of a useful result that can go into strength of the farmer or strengthening the farmer, and particularly, and also look for energy optimization. These days, there are 2 issues. One is energy maximization, that is whatever energy forms we have, that is conventional, non-conventional, we would like to maximize them because the requirements of energy has become abundant now. In fact, there is always a shortage, there is always an outage, we see that. So therefore we require to have a lot of augmentation with reference to energy sources, that's number 1. But you all must understand that productivity is not just a mathematical formula output by input. Productivity is not a mathematical formula that we only maximize all the time. There is something called minimization. Jet is nothing but minimize all the losses and ensure that there is an elimination of waste in all forms. Elimination of waste in all forms. Even electrical energy, when you talk about, there is a lot of wastage. We talk about various power losses, talk about various harmonics, we talked about various kinds of fluctuations in the loading, see on various types. This is all water wastage, basically. So we would like to have a system, not only looking at energy maximization, we look at a system which will be able to support us by the energy minimization or energy optimization. That means we not only produce energy and use it and waste it, we always conserve the energy in order that we do not waste it at all. And we have intelligent methods to ensure that we don't waste any energy or we save it. Otherwise, we understand the pockets where the energy is getting lost, and we plug in those pockets that we ensure that there is no more loss of energy there, and we always ensure we master the technique of optimizing it. So this project is energy optimization project. So I felt that instead of giving a very strong level application, I thought I would support Dr. Shankar's thought process, our college initiative into an interdisciplinary engineering requirement. Not just electrical alone. Today, if you ask me what engineer I am an electrical and electronics engineer. I am also a communications and control systems engineer. I am by and large an aerospace engineer. And I am also a space and satellite communication engineer. And I have done enough of that. What I mean to say is anti-aircraft and systems electronics. Today I have forgotten what exactly I am. I am a mechanical engineer, I can say, because I keep teaching a lot of mechanical students. And last I went to one of the VIET, Bharat Institute of Engineering and Technology. I was assessing the civil engineering projects. And so I took one civil project as one of the best projects, actually in VIET. So I am also a civil engineer. So therefore, today one has to be a wholesome engineer. A holistic engineering understanding is required. You may be very good in your core domain, but you can't ignore the other domains. You have to have knowledge of all other domains. Particularly, I want to share with the electrical and electronic system students that you can't afford to miss the fundamentals of mechanical engineering. Please understand that product engineering is primarily mechanical. The product design is mechanical. Whether you talk about stability, whether you talk about entropy, whether you talk about thermal management, whether you talk about isolation, whether you talk about vibration, shock, environmental effects, eco-management, and whether you talk about ingress protection rating, or whatever you talk, these are all mechanical in nature. And for all those who are in electronics, our entire RF electronics is precisely with reference to mechanical. Whether you talk about your PSW or whether you talk about your antenna gain, or whether you talk about radiation patterns, and all these things finally, how finally you shape that mechanically that antenna. We used to use log varied antenna. We know a solder defect can change the entire radiation patterns. If you take a cavity max spiral antenna which has a circular polarization, when you talk about RF electronics, the entire thing can change. One small mechanical issue can interfere with the entire radiation patterns of it. So therefore, mechanically, product engineering means mechanical. You require it. Particularly when all your electrical hardware is going to be resident in the enclosures, which have to be IP protected, which are supposed to be in some different chassis, you require a lot of mechanical engineering. So therefore, I felt that a project should have core electrical and electronics, no doubt, and also it should have modern subjects like AI, and it should have a lot of mechanical engineering understanding, and it should have some civil discipline in terms of soil, in terms of understanding what are the various kinds of forming reasons, etc. Soil, different kinds of applications. And so therefore, from basics to the advanced, we should have one subject, and that subject should be in a position to drive a great project. Now, before you all have doubts, I would like to share one thing. That this is going to be a big project, undoubtedly. So you may have some kind of a doubt or an aspersion and ambiguity that how to go about it. Can a college level will be able to go about it? I will assure you, colleges, projects of this nature are worldwide. If you take, Agrarian, if you take Georgia Tech, if you take Purdue University, if you take so many other universities abroad, including Cambridge, they're all doing already. The engineering students like you, that is not that it is something impossible, number one. Number two, then they fund. So you may have thought of it in the beginning that there is one kind of a organization which may fund you on this engineering college, and you will be able to do this kind of projects out of that fund or out of that grant. Not necessary. According to me, suppose if somebody is supposed to promise you some 80 lakhs, 10, 100 lakhs or whatever it is, and is not able to do today, there is no need to worry. This kind of projects where it is supposed to be product driven, where there is going to be finally crores and crores of money which is going to be saved and used. There are lots of initiatives in this country at this point of time by a number of industry makers who come forward to do it, by government initiatives which are there in more than one, not necessarily only one, and it not necessarily is pertaining to only Andhra Pradesh. So there are a number of opportunities as far as funding and doing is concerned. The third point, sir, will it become a full-scale product for me to use it? You may not be in a position to develop it unless it is commercialized completely, but you will be able to bring it up to some prototype. Even if you bring one prototype and do it, what is the advantage of it is, you will learn a lot of subject from it, first point. You will learn a lot of fundamental first principles from it, how to go about it. You will get a lot of knowledge about it. And if you are a power system student, I understand some MTech power system students are here, somebody. Correct?
Power and industrial place.
Power and industry. So they will be able to understand phenomenally of this.
Power and industry is main down.
Yeah. So what I mean to say is, you will be able to transform yourself into a theoretician, that means as a student who is learning only some subject, into a practical engineering enabler, whereby you will be able to look at product. Finally, all engineering is only with reference to making products. If you are not thinking of a product, you are not an engineer. If engineering is Brahman, the product is the creation. Please understand. So if you can't transform your thought, your learning into a product, you are not becoming a successful engineer. Engineering is not just picking up how it works. In the process, how we are going to build it, how we are going to make it. So when I am presenting this to you, forget about the entire background. Who is going to fund? Who is going to make? How do we make? Whether we can make? Is it possible? Or is the money available? Those questions can come later on. At this point of time, as I am presenting to you, enjoy the listening, enjoy the learning as a good engineering project. How do we go about it in a modern sense? So I recommend that you accept it as a beautiful interdisciplinary engineering project, which can be a good initiative. It can be meant for a good research and incubation center here itself, and there will be some companies to come forward to fund it and support it. Not to worry. Right? With this background, we have some more on that. I proceed. Here, the subject is AI driven, artificial intelligence driven. Adaptive, that means it is supposed to balance itself with the ego, that means entire ego management. It is not something which is supposed to be rigid. It is supposed to be platform adaptive, ego adaptive, the system adaptive. That means it is supposed to be adjusting itself to a kind of an environment. And we make things adapted to the particular system and environment. Energy intelligence, that means we are trying to make some kind of an intelligence project, intelligence unit. That means it has to have its intelligence to understand itself. What is an intelligence? Intelligence comes from a critical examination. Where, which, how, why, all those things. No hows, no whys, wherewithal we call it. That's all about intelligence. Intelligence means you should know what is that I am supposed to do, where am I, what is happening, what should I do, how should I manage it, how should I balance it. All these questions are supposed to be with reference to the intelligence. platform, of course, and which is going to be a prototype that we are going to talk about for power efficient industrial drive systems in agrarian infrastructure. Agrarian infrastructure means agriculture we are talking about. I am taking on agriculture because we feel that the government is giving a lot of subsidies to the various farmers. Let's understand the problem. The farmers and the agricultural sector request substantial electrical energy, no doubt about it. Now, consider that a lot of wastage is there. Whose money is it? Government's money. You understood? And we waste it. That means we are not able to use it effectively. First of all, we are wasting it. Second, it is subsidized, so that we are losing on two accounts. We don't pay for it. That is, the fellow who uses it, farmer doesn't pay for it. Government pays for it. That is, you and I pay for it. First point. The second point is, and what you and I are paying for it is lost. It is wasted. So how can we allow it? Suppose if you are burning some lights and some air conditioners in your house, I am paying the bill for it. And do I expect that you lock up your house, switch on all the air conditioners and go on a holiday, and I keep paying the bill for it? It is run wastefully. Do you like it? You won't like it. This is the same thing. There is no difference here. I found that in the farmer sector, a lot of industrial drives are kept in use. They don't pay for it. There is a lot of government subsidy on that. And we are not in a position to arrest the leakages. So that is the problem. The problem is very mega in size. It's not a micro size problem. If we protect it, perhaps we are talking about thousands of crores of saving. So therefore, the problem assumes importance. It becomes important because what is the money that you are going to save? What is the alternate use of that particular money? So that makes sense. So we have taken this application. That's the background for this application. I spent enough time for it. Let's proceed quickly. I will stop at one point and ask you any doubts. At that time, you can ask me a doubt. Okay? Until then, I will flow in my own speed. Okay? So that we complete this in a finite time. AI-driven intelligence. Don't forget, this slide is not important. What is the aim? Aim I have already explained to you, so therefore there is no need to deliberate on that. So project positioning, it's a scalable project. What is a scalable project? Are you able to apply in this small farm, small garden, go about it? Can I do it at one farm sector, one cluster, and one cluster to one farmland to many of them? That means one feeder to many feeders. And after that, can I extend it to state? Can I extend it to district? Can I extend it to state? That means it is scalable. We are trying to work on a scalable platform. So that is a scalable platform, AI-driven, I mentioned to you, energy intelligence platform. And what this project is not suggesting you how a motor replacement program is, how a standalone hardware device is, how you are going to work on some kind of a theoretical approach for some kind of a thing is. No. The problem is complicated, and that's why we are working on this. If it is so simple, I would have left it to school level. If it was so simple, I would have given it to the polytechnic students, or I would have given it to someone else. We are working at a higher level. So therefore, the problem has to be substantial, it has to be complicated. Please understand. And if I am involved, obviously it has to be tough. So then only we will be able to attempt such problems. Next, that is the strategic intent. Next, project definition I have explained. We will go into. See, this is here. Let me explain. First is industrial drive systems. There are so many industrial drive systems. How is this normally worked out? For those who are not aware, I will tell you. You are a farmer. There are about some 10 farmers across the region. Each farmer has got some kind of a farmland. And in each farmland, which is running about some hundreds of acres or something like that, or 50 some acres, I'm not talking about small thing, I'm talking about in a mega way. He has got different types of clusters. In each farm, there are clusters. In one cluster, he is growing one kind of paddy or something like that. In another one, he is growing some kind of grapes. In another one, he has a mango garden or something like that. In another one, he has got something else. And particularly if you go to the west of Andhra Pradesh, you will find people are using the commercial crops. There are about two of them, two crops a year. Some of them have three crops, and some of them, of course, single crop. They go for one type of crop once, another type of crop, another one. By the way, I have done extensive work in understanding this farming and agriculture. So that's why I'm able to explain it. So there are different kinds of farms. So when we are talking about various industrial drives are there, right from motors and pump sets to harvest control systems and storage. If you are talking about perishable kind of things, there are various storage drives for that. There are cold rooms, cool rooms, warehouses, and there are various kinds of shelters. There are so many power drives we are talking about. It is not just some kind of a motor and pump only for irrigation purpose of water or something like that. There are some dry irrigation system, there are sprinkler irrigation system or something like that. There are so many types of drip irrigation system. There are different kinds of farms. There are different industrial types. So we have got so many industrial types, and after that there are adaptive control and analytics for it, and then we are going for AI intelligence. Most important thing is AI intelligence. It is the AI intelligence that makes the entire product very intelligent enough at this point of time. Okay. So, what is the advantage that a college or institution takes it up? I am looking at, first of all, it's the research. So therefore, we start from a concept to the prototype. We build a prototype here. Once you have a prototype, everybody will believe, yes, you have a product in hand. Then the angel investors will come forward. They will invest, or some industry major will come forward. They will try to sponsor you for making that particular product happen. And then you are going into a kind of a development scenario. Then you make a full field development, field deployment. Then if you are successful, you get a patent of it. Then you will be able to commercialize it. If an institution does it like this, so many Western institutions today, I want to tell you, like Purdue and take Carnegie and take Massachusetts, take Harvard, all this, they get royalties. A lot of money is given by the royalty itself. See, please, institution like College of Engineering is not only here that students come, we teach and we send them away. No. We are also doing a lot of research here. We are engaging the students' capability for doing that research, and that research is producing products, and those products are patented, and those patents are giving us the royalty. Then we give it to the various industrialists to do it. Like you don't know whether it is, you are aware of Cummins. Cummins is a big, what I mean to say is, it's a big automobile and also an industrial platform again. And Cummins has got a lot of interest in Purdue. Every Purdue research project is going to Cummins. Cummins puts lots of money in Purdue University. I'm telling you frankly, lots of money. So we want like that some industries to come and put a lot of money in this Anantapur Engineering College. And so this entire knowledge is basically used. So we make patent and we make a commercial. So this is a long thought, but let me proceed to the next one. Institutional leadership. This is now we are working in two formats. Obviously, all things cannot be in one place. Institution has its own kind of capability. Outside world also has got its own capability. Suppose I am from industry now. Obviously, I have some 46 years plus of industry potential experience, having worked in many disciplines and having advanced in many kind of engineering projects and products, having developed many things. So I have got phenomenal experience potential in making the products. At the same time, a lot of research capability is there in the academia. So we would like to combine, we would like to have a kind of unison of this academic potential, that is academia capability in terms of research and drive, and also the industry capability through me, and then we will make this particular thing happen. So therefore, we have got an institutional leadership, we have got principal investigators, we call them academic leads, and we have a strategic, the industry advisory. In this particular case, say I am the advisor of this particular project. I am supposed to give you all that know-how and all that wherewithal, all that kind of industry experience and industrial capability, how to go about it, how to build it, etc., and all the guidance. And there is a lot of institutional leadership here, and then we do it, and we take some government structure, and the government structure is helping us a technical project steering committee. We produce those things, and then we do about the execution. So this is about the combination. So there is one stakes from you, Stakes from me, stakes from the government, and then we give a kind of a beautiful product that the nation enjoys finally. Okay, next. What is the core problem? Understand the problem first. Before you engage yourself into any kind of a project, wherever you are, understand the problem. The agrarian industrial lives operate with a very limited or really no intelligence. At this point of time, other than the protective interlocks which you put, protective systems which you put, you got a kind of overload protection, overload relay, overload release, and things like that, and some kind of phase imbalance and some things like that. Some normal protections are there. They are the ones when the problem happens, then they stop, then they take over. That means when the overload happens, there's an overload, the relay circuitry that comes in picture. When there is a phase imbalance happens, then obviously there is some kind of a corrective circuit. We are trying to avoid some damage, but we are not trying to program how it is going to come, predict it before, have the intelligence, and ensure that it is stopped in the building itself. We are not able to do it. We do not have intelligent systems. We have only protective systems at the moment, and there are also not many, and we have only a couple of them that also. So therefore, we would like to have very intelligent systems. Intelligence is not there at the moment. Key inefficiencies is suboptimal load. Suboptimal load. We are talking about it, and poor power factor. I don't know how many of you are aware. And this power factor fluctuation, it in fact kills it. You are all aware of what the active power load is with reference to power factor management. You are aware. So, and there is a lot of distortion at this point of time. We do not know how much of power is wasted. In fact, in addition, actually, that the true power we are not able to engage ourselves with. So, harmonic distortions, and we are talking about idle running, energy wastage, absence of predictive maintenance capability. We do not have anything called reliability-centric maintenance and other concepts even today in the agrarian sector. So all these things are there. So there are so many system level gaps, and there are a lot of resulting impact is increased energy consumption and very high subsidy burden we are having, and that is the core problem summary. So we'll go about it. Now, energy inefficiency landscape, I think I'll skip this because you are already aware. So we are talking about, before there are a lot of limitations and the various issues with reference to static configuration. It is not a dynamic configuration. It is a lot of manual intervention is there in many of them, and no predictive or adaptive control at this point of time. That is the way the agrarian sector is run at this point of time. One is that we are going to make real-time adaptive optimization. We are going to put a lot of AI in this, and predictive diagnostics and cluster level actually load coordination. We are going to have different layers, different ways of coordination. So, and at the end of it, we are supposed to do a baseline energy audit. When we do the energy audit before and after, before how much it is, after how much it is, the audit must explain to us that no, we have done a substantial energy optimization with a resulting a great financial impact, which is a positive impact. And I'm leaving this presentation here. All of them can go through. If there are doubts, please ask me, no problem. I'm touching only important things. There's no point in running the full scale. Knowledge, sir, you can give it universal. In this, what I have protected right now, I want to share with you. Even in this detailed presentation, I have not given the design. I have given the entire concepts, and students can design also. They can go. I am giving the initiatives, but they possibly will not be able to reach the level of my way of doing it, and it takes a lot of time. So I have inhibited myself to give you the exact design, exact circuits, exact AI module. But I have given you everything else. I am not hidden. I feel as a teacher, I can give it to you. All of you can use it. And students who are doing the theoretical projects here, if they can take this and produce as a beautiful project, and I'm sure, actually this can be one of the thesis projects for the doctorates. I want to share with you. I have already sent something of this to the foreign university, and they are doing it. This is being attempted somewhere in the foreign. So there are broad objectives, there are technical objectives, and there are measurable actually targets their institutional policy objectives. Technical objectives are actually produce a scalable AI-driven prototype. That is a technical objective. What is the measurable target? Whether we have done it, whether it is field implementable. I am very sensitive to disturbances. You must, I apologize for it, but I am very sensitive. Right? Kindly tell them this. So, and measurable target says whether we have done it, what is the kind of kilowatt absorption which we are talking about, what is the measurement we have. I am going to give you an example, a rough example at the end of measurable targets. I'll give you a beautiful example, that is in the part 2. Institutional policy objectives, how do we go about, how do we fund it, who will do what, how we do monitor. Any big project requires some kind of monitoring. Somebody has to be the head, somebody has to question you. Why have you not done it in time? Why are you sleeping? Why have you not completed it? It should have been done yesterday. You are postponing it, you are procrastinating it, you have spent more money, you have not done, this is not done, this is not done, this is done. So there must be some kind of a policy objective, administrative objectives. So therefore, these things are supposed to be on one side. So institutional policy level 1, that we will come to it in Tech 2. Tech 1 I am going to talk about only technical. Okay? Right. I have already defined it. So what is the product philosophy? We will understand what is the design principles. And we have something called a concept of modularity. What is modularity? If I am using one here, I would like to use the similar one here, similar one here, similar one here. I can't design about 10 types. I can't design about 12 types. I would like to design one type and I would like to use it wherever is possible. You understood? No? So that is modular in design. Suppose if there is an electronic warfare system, I would like to design it universally across all the ships. It is not that no, I will design big one for a big ship, small one for a small ship, and different kinds of electronic warfare systems for different types of vessels. We don't do such things. Similarly, if you are going to have a head-up display, whether it is a fighter aircraft, or whether it is a transport aircraft, or whether it is another logistics aircraft, all the things we would like to do same. So most of the cockpit electronics are same. Suppose if you design some kind of a flight data recorder, it has to be universally same. You can't have different ones for different things. It is not possible. So modularity is that you would like to have same thing common, standardized, codified, rationalized, and you would like to have modular everywhere you can use it. That is the point. By the way, I would like to take aerospace examples because with these hands, I have worked for every military aircraft that flies in this country. Every military aircraft that flies in this country, perhaps I must have contributed with this. So aerospace is close to my heart. Navy is close to my heart. I will take many examples from there. So intelligent framework, we would like to have something very intelligent. If it is going to be only some kind of relay all the time, there is no point in making it. There are so many people who are making it. Deployment philosophy, it must be non-invasive integration. Suppose I want to come to your drawing room. I want to put some kind of a beautiful art piece. It is not that I am trying to destroy your walls. You remove this, you remove that, you remove this, then I will put this. No, nothing like that. The farmer is doing what he is doing. The state electricity board is doing what they are doing. Everything is they are doing. I am trying to enter and put something there, non-invasive. That means not disturbing anybody, not actually reflecting on anybody to do anything else. So non-invasive procedure. That means we are not going to do anything invasive. So non-invasive procedure we are going to do. That is the deployment. And core value is we are going to actually enhance the value. Next. Layer 1. First of all, we sense where are the problems. I will explain to you. Second, we control, we understand, we analyze it. The third, we do the AI optimization. AI comes in large amount of data. How do we analyze it very fast? With all speed, with all accuracy, with all beautiful algorithmic value. In terms of accuracy, in terms of speed, we should be in a position to do it very quickly, very reliably, without flaw. So that is AI optimization engine. Then another thing, once we know the result, we should know how to report it to a next level and we should be able to control it and scalable monitoring platform. So these are the various layers which are there in the architecture. I am giving the tech one, which is the technical side first, then we will proceed. So what is this first I am doing? In layer 1, I am trying to do at a drive level. What is the subject? Subject is there are various industrial drives, and all these industrial drives are required for some agrarian purpose, and they are required in a farm. And on the farm basically are connected to some feeder stations, and so therefore we would like to have energy optimization. So the problem is starting at the industrial drive itself. And how is the industrial drive working? There is some kind of an input power for it, and there is a mission, and it has been designed for some kind of performance, and it is supposed to work in some kind of an ecosystem. That means if there is some kind of a constant voltage application for it, if you switch on something else or something like that, suddenly there will be some drop. And otherwise, if you switch off something else, or if something else happens, there can be an overload ramp. So there any kind of a performance actually impact will be there on the drive, depending upon its own deficiencies, depending upon its own eco management, depending upon various other aspects which are interfering with its functioning in that particular state. So we would like to understand all those things, and we don't want you to understand. We want the drive to understand. We want the drive to go about how to make use of, how do I run it. It is not like that, in the morning onwards, the parent is telling, get up in time, go to the college, do well, professor is telling you, learning, this is very good for examination. Nobody is guiding anybody here. The drive itself is self-guiding it, self-directing it, self-correcting it. That is called intelligence. We are talking about such energy intelligence at the drive level. That is first one. Now, such 1, 2, 3, 4 drives, we take it is at the cluster. So we take about the cluster level, and we take about the cluster level. Then all such clusters will come into another level. That is scalable we are talking about. So that is another level. So then we get into the architectural significance. This is how we are going to implement the solution. I have not yet come to the solution. I am explaining how do we reach that solution. Before that, I am giving you so much of information to you so that you reach the understanding in a very stepwise manner. You will not be able to see it from there perhaps, doesn't matter. Anybody doing any project, first you have to have an IO model. Everything is an IO. There is an input, there is a process, and there is an output. We know what are the inputs, we know what is the process. The process is supposed to be done by the product. Then what it is supposed to give as an output. So we know the deliverables, we know what is the input level actually, and then we have the process. So the process becomes actually what I have written as the process here, that becomes the product. That becomes the product. What are the inputs? Inputs are various kinds of information which we are talking about. What is the voltage, what is the current, what is the harmonic, what is the power factor, what is, if it is mechanical, what is the kind of turbulence, what is the vibration, and what is the kind of temperature, what is the kind of humidity, what various issues. I do not know how many of you are aware. If you are in the vessels and ships, you will come to know. The motor performance can be absolutely where it is fitted. Suppose if it is fitted in the boiler room, a boiler actually is for a particular boiler, you have got extraction pumps and circulating pumps, and you have got drain pumps and various things. In boiler room particularly, you will have too much of moisture, too much of condensation, and you will be sweating yourself. Think about it on the motor appliances. There will be a lot of wet content on the motors. In fact, even if they have got highest ingress protection, there is something called insulation for every motor. Insulation resistance. And if it drops actually, if the insulation resistance is not even 1 mega ohm and things like that, you try to stop that, it will just flare up. And after that, you have a bigger problem in hand. So everything has got an eco management with reference to its functioning. So therefore, we are understanding what are the various ambient issues, various mechanical issues, various electrical issues. These are all the inputs. And then this is the drive which we are talking about. What kind of product must be there for drive to understand it. And here outputs are, you are measuring various issues related to the harmonics, power factor loss, power factor compensation, and things like that, and the various aspects of it. So this is an IO model. Actually, every project, if you are starting, you should have a clear IO concept. That is inputs and outputs, what you need to have. The block in between is your effort. Okay? What outputs you must have, that is the expectation from you. That is the deliverable. Inputs is what are given to us. So if you do not have an IO concept in your mind, you will never be able to design any good project or product, sorry. Now we'll proceed to the next one. Are you able to see the slides from there? So we'll go to drive level edge intelligence. I am using the word edge intelligence. That is, it is used at that particular edge. That is where actually it matters. So therefore, I am using that drive level edge intelligence. I am calling what I am going to put at that drive, I am calling it as energy intelligence unit. That is the terminology I am using it. I am calling it as an EIU. So finally, we are going to design, we are going to do the EIU for every kind of a drive, and we are going to scale it, and we are going to look at it as finally. That we will tell you. So we are going to do edge intelligence unit. We are going to do edge intelligence unit. Functional capabilities, I will mention to you over time. AI and predictive capability. This is where a lot of work is going to be there. So this is architectural advantage. Basically, it is going to be modular. It is going to give local optimization. We are talking about local optimization reduces dependency. That is, you require a centralized. It works as a centralized control system. It enables a faster response and automatically settles down on itself. So it comes into a beautiful energy management. Now, how many disciplines are there here? I want to talk to you. Number one, obviously electrical, obviously electronics, because you are going to use some beautiful interoperable and interface modules, which is going to come state-of-the-art electronics. No doubt about it. Second, next you are going to use AI and software. Definitely. Then you are going to use product design. Definitely. Therefore there is a mechanical engineer. And you are talking about farming, agriculture, soil, and various ecosystems, civil engineering. All disciplines are there in this. So it's a beautiful project for a college to launch upon a kind of interdisciplinary research and incubation center. These days, I recommend to the colleges not just have only one electronics R&D incubation center and only for mechanical. No, you must promote at the college level. The students must put together and pull together. They must work interdisciplinary projects. So therefore, they have an empathy, they have an understanding, they have an appreciation of what actually the other domain is. They should know what the other domain is. Otherwise, these people are going to be straight away only in verticals without knowing what actually is expected of the other engineer. And suppose if you are in a team tomorrow, and if your mechanical engineering boy goes on some kind of a thing, you mean to say project will come to stop, so has gone, so I'm sorry I will not be able to do. No, for your information, I happen to be in the direct core R&D team. I used to correct number of mechanical drawings. I used to correct number of aerospace drawings. The plenty of drawings for the super indigenization project which have been done by me. So here you have to be an engineer, first point, and you have to have multidisciplinary knowledge. There is no option. In the modern engineering, you can't have verticals alone. You have to have a lot of actually width and breadth in terms of understanding the technology know-how. That's how the foreign universities have their research and incubation centers with multidisciplines. So I recommend such a thing, and this project is actually keeping that kind of a capstone project in mind, where it is promoting the interdisciplinary things. Next, cluster level aggregation I mentioned to you. Central intelligence backbone is basically with reference to a central analyzed platform. I will take you to the diagrams now straight away so that I can explain. No point in having theory you can read here. So here you can read. These are sensors, these are actuators, these are motors controls basically. There are various conveyors and other things, other drives. All these things, there is a sensing layer, there is a control layer, there is a AI intelligence layer, there is an analytics layer here. All these are seen at the different levels. There is a drive level node, it is going to the aggregation hub, then it is going to major operation hub, it is going to central intelligence hub. So we are going to scale up like this. We are going to have a prototype at the driver edge level. We are involving so many layers. We are doing edge level optimization, and then we are projecting and making a product which is at the cluster level. So this is the concept. This is the scalable AI driven. AI is coming into this. Scalable is run up in all this space, and this is energy intelligence platform right from the drive level node to the top level. Okay. Now we will proceed to another one. And I am going to tell you here in your book which I have given, actually DBR, and this can go for kind of a grant purpose, etc., detailed project report. The one who scrutinizes it, he scrutinizes it at a different level. So I have not gone into a kind of very fine details. And I have not exhibited the entire design. I am sharing with you. But you can ask me questions, no problem at all. There is no secrecy here. And I am using a concept which is the industrial standard already. What is industrial standard? If I say 4-inch 19, 4U 19-inch rack, then that is the industrial standard I am using it. There is some kind of ingress protection associated with it. Anybody? You are all aware of ingress protection? Students? MTech students, no? You are MTech students? What is ingress protection? IP? I may not ask BE students for this, but you cannot say that I don't know. And please remember, MTech students, you have no curriculum whatsoever. You have to work like this. If you think that what is going to be taught to you in the college, or what project you are going to do, or what thesis finally you do, that alone is the world, you will be mistaken. You have to have a level of knowledge which is absolutely industrial appropriate. You have to have a broad level of knowledge. You have to have lots of engineering concepts. An undergraduate student can be excused, perhaps. A postgraduate student will not be excused. A postgraduate student of our college must be at par with the postgraduate student of Harvard or Carnegie Mellon or George Tech or some kind of, Illinois University. Or we are talking about Stanford. You have to come to that level. And that is all in your hands. Your professors alone cannot help you. As a postgraduate student, I am asking you, what is ingress protection? Ingress protection is with reference to enclosures. Any enclosure, we have got something called dust, we have got something called moisture. What is its dust protection level? What is its moisture protection level? We would like to have it as actually airtight integrity or dust tight integrity or moisture tight integrity. There are 2 digits for it. That is, first digit explains the dust tight integrity, second digit explains the moisture integrity. Second digit is up to 1 to 8, first digit is up to 1 to 6. If I say 56, IP 56, it means IP of the level which is up to the standard 5 with reference to dust tight integrity, standard 6 with reference to the moisture integrity. IP 56 or IP 58 is the one which we use it for flight data recorder, which can be used, which can be dropped in the desert or which can go under the ocean. Please remember. So we have to have IP standards for it. Next, what is the U? Anybody? Students. What is U as a form factor? If you are using a unit, 1 U means what is the height we are talking about? How many types of standard form factors we are going to use? U is the standard notation. U means 1.75 inches. If I say 4U, it is 7 inches. 4U means 7 inches. What is 19 inch? 19 inch is the width we are talking about. It's a rack. That is a standard, industry standard. So I have taken an industry standard of 4-inch 4U 19-inch rack. That means it is going to be, that is, it is about 7 inches and it is going to be about 19 inches. 19 inches is 482.6 mm. That is the standard which we use. There are so many methods why it is used and all. I need not go into it, that's not the time now. But after that, it's about some 300, 400, 450 mm, that is the weight. So that is the gadget which we are talking about. And that's the gadget which we are going to use at the feeder level as the AI unit, the non-invasive application which we are using for this particular project. What is your job? Your job is to find out if you are going to be a student working on this with me, then I will be asking you or I will be training you how to make this energy intelligence unit at the dry level, how to make a cluster level, how to make the feeder level, which is the 4U 19-inch platform. And once you make that, you are going to fit it in a different way, and it is going to self-maintain, self-energy maximize, self-energy optimize. We are talking about thousands of crores of revenue being saved. That's the project. Okay? In this, what is, I will ask questions, postgraduate students, please. And I want to share with postgraduate students, if you just have got an MTech and going away without knowing what the word is, first of all, your MTech is to be certified by you first, not by the college, not by the university. When you take the MTech certificate, you have to think, yes, I am an MTech. Yes, I am fit for it. This certificate, I deserve it. That feeling you should have. Postgraduate students, please, I am sharing with you. Certificate is not what the institution gives you. Certificate is what you give it to yourself. Yes, I am a competent engineer. This, if you remember and if you recall, you will be a good engineer yourself. And so we have at the drive level, we have a small module. This is going to be an intelligent module. This intelligent module is going to be AI-driven module. That means it will have its own kind of firmware with it. It will have its own AI module. It's a very, I have shown it so big, it will be so small. It will be so compact. It will be just put inside one control box there. If you got a starter box, if you got a control box, it will be somewhere inside that. It will beautifully remotely connect it up also. Sometimes it cannot be wired. I am going to make it remote sensed. Perhaps you can wire it, depends upon what it is. Right? That depends on your kind of ability to make this happen. So we are going to make this level module. That is the 4-tier distributed intelligence architecture I am talking about. In the concept level I am giving you. So first is this. You will make this module. So we will make it here in our college. It's not difficult. After all, what is required for it, we know. And what is actually, what is the pump, what is the starter, what is the industrial drive, we can have it here. And we will be able to do it. And we will be able to feel it. And we will be able to check it whether we are able to do it or not. Yes. And we can design that. It is a college project. Next, such drives 1 to 10. Then it becomes a cluster. Suppose all of them are being fed from one distribution station. What is the concept? One industrial drive will have one starting point, one starter, some kind of a starter panel. Some cluster of them, all of them are fed from one local distribution, that is distribution board. From all of them are being fed from one transformer, one main distribution panel. And all such kind of a thing finally wired from at one feeder station. So therefore this is all scaled. So we are talking about introducing this AI and this modules at different levels. So this is at the first level, basically. And you are asking about why it is so important. Because the importance is not in saving for one pump or one motor. When you finally have it for a cluster for a big number, then it makes great sense in terms of revenue management, energy management. Energy management is not there. And you all are aware that if you want to start a particular motor or something like that, the starting currents are very high. And you know that running currents are in suppose 1 to 7 times is the starting current high, or 3.5 times is the running current. You are all aware of these numbers. Okay? And of course, I am not taking a regular power systems class or whatever it is, but I want to share with you. You all must get fundamentals very clear. By the way, a great scientist is one, not who knows very high concepts alone, who will never forget the fundamentals. Remember this. A great scientist is one, or a great engineer is one who will never forget the fundamentals. What are taught to you, even in your first year BTech session or intermediate level, what is taught to you, you cannot forget. Remember this. And when your fundamentals are very right, your knowledge growth also will be very sound. If you don't have a base properly, If you just have something mugged up and just write some examination, you may get some grade and marks, but that doesn't prove you are an engineer. Remember this. I will give you an example afterwards. So cluster level, we are going to have, that means a few of the industrial drives. At next level, at the distribution level, we have one more unit. I have shown big in the screen. It is not so big. It's going to be very small. Because the final product itself is about 7 inches and 19 inches we are talking about. So these things cannot be so big. So next is the farm level. What is that? A farmer, he has got 4 clusters. In one cluster, he has got a mango garden. In another cluster, he is putting some kind of, some cotton plantation. In another one, he has got a paddy. He has got some other crop. I mean, in terms of about, there are landlords who have got some 200 acres, 250 acres, etc. I'm talking about such landlords. They have got different ones. Or he may have given for the higher, cow and duck. So he may have given to one person here for one. He may have given to another person for 1 year. So there are different clusters. So at the farm level, it is going to be integrated. Because he must have bargained from the energy station, that is from the AP Transco or whatever it is. He would have taken, you would have taken some 500 kilowatt, you would have taken some 1000 kilowatt, you would have taken some 2000 kilowatt or 5000 kilowatt, depending upon that. He may have put, of course, some solar these days. Everybody is knowledgeable, so everybody is putting some solar, etc. But still, he has got some kind of installed capacity. Now, you know how that installed capacity is there from all. Suppose if you have got some 1500 kilowatt, do you know how, 1000 kilowatt, if you have got your requirement installed capacity, do you know how to go about it? He goes for 3 transformers. He goes for 500 kVA, 500 kVA, 500 kVA. That means 3 500 kVAs. At any point of time, 1 and 500 kVA and its entire electrical paraphernalia will be under maintenance, under the predictive. The other 2 will be serving the board. So like that he will be going. This is called a reliability centered management. Anyway, I don't know whether these are all taught, but these are very important. Next is at the farm level, we have one more gadget. At the feeder level, we have this particular gadget. And actually, in the cost of developing this, in this entire project report, in the cost of developing this, I am absorbing the cost of all this. I am absorbing the cost of all this. You know what is the cost of developing this? I have put it approximately. I am just telling it. I am giving a figure. There can be some intelligent boy who can do it much less. But perhaps I must say, on any project, by any product you produce, there are 2 costs. One is called NRE, another is called RE. What is RE? Recurring expenditure. That means if you continue to produce run-on-mill productionization, what is going to be? It's the recurring expenditure cost. There's something called NRE. NRE means when you develop its prototype, or its environmental qualification, or its testing, or its documentation, or its one-time expenditure for proving it, you must have gone through it. So NRE amount is amortized over what you are likely to get in the next 15 years or 4 years of production. You amortize it. So NRE becomes a component in the RE. So I have taken a huge requirement for productionization of this. I have amortized that NRE, non-recurring expenditure, and I have amortized that production cost non-recurring into the recurring, and I have taken it. It is about some 5 lakhs, 4.5 to 5 lakhs. And we are talking about thousands of them being sold, not 1 or 2, entire state. Entire state, we are talking about so many crores of revenue being protected. So this is the concept. We'll go to the next one. And this is going to be in a fine print, what I have produced. You listen to me, and after you can ask questions. Otherwise, you take the slide and you go through it. Okay? Possibly, I could have put in a bigger way. I can amplify it in different way and I can explain. But I am explaining in this particular lesson, in this class, or in this session, I am only giving a kind of a complete conceptual orientation. So now if you slightly do it now, we have got a formula 1, a formula 2, a formula 3. N1, N2, N3. I have taken 3 formulas. Please appreciate it. He has got cluster 1, cluster 2, cluster 3. That means 3 kinds of clusters. That is same formula. In one form of his own, he has got 3 types of clusters. Formula 2, he has got cluster 1, cluster 2, cluster 3. Here 1, 2, 3. Now for this farmer, for this particular cluster, he has got 1, 2, 3, 4, 5, 6, 7 drives. There are 7 drives. The drives are so many drives. The requirement for not only for the irrigation purpose, for harvesting purpose, for the storage purpose, for the conveyors. Grain conveyors are there, you are there. There are so many of them. And if you go to any kind of, by the way, in our India it is different. If you go abroad, it is a feast to see what a farm. He is the absolutely most modern man. You will be appreciating that a Stanford engineer will be a farmer there, and he will be doing fantastic farming. I used to go from Heathrow Airport to Cambridge. It used to be a 2.5-hour drive for me, and in my way, I used to pass through various farmlands, most modern drives. And I will tell you one thing: we all do really lot of physical labor. They do a phenomenal amount of output every day. Throughput is very high. Everything is automized. Everything is mechanized. So I'm talking about there are so many drives here. Are you fine? You are comfortable? Okay. So this, you've got so many drives here. This cluster, he has got these many drives. This is the cluster. This cluster, he has got so many drives. This is the cluster aggregator. I use the word aggregator. This is the cluster, this is an aggregator. All these clusters put together, this is one form. He has got a kind of clusters aggregators are here. Now 1, 2, 3 farmers, I have taken all of them. They are all actually fed from one feeder station. AP Transco has got one substation at one place in the power systems in the scalable format. There I am putting this. This I am putting it as that 4U 19-inch block which I am talking about, which I am designing. What is it going to have, I will explain shortly. But this is the way the concept is there actually. And I have given this kind. And the next slide will have fine specifications, small, tentative specifications. If there is any kind of students that want to do it, or somebody wants to do it, I have given some guidelines to them in that. I have given some guidelines to them. So you can't read this fine print, leave it, but the concept is same. We are talking about the same kind of a block which is to be made. I have given real world deployment analogy, that is the farm scenario. How do you do real time means what? What is real time? When you are doing it actually on the spot, how you are handling it on the spot. Suppose if there is an outage here, I will tell you one thing. If there is an outage somewhere at the feeder station because of some problem, so what happens? The entire thing will suffer, no? You agree with me? Then how do you cope with that outage? How do you cope with that outage is the question. So therefore, we have so many self-adjusting, self-built, self-correcting, self-optimizing features with AI built into it. Okay? These are all available in my book, and these are all for those who would like to go about doing the project. I have given some fine specifications: how many watts, how many things, what should be the weight, what should be the componenting, what should be the active load. Like that, I have given some specifications, and these are all pertaining to the design aspect of the problem. Now we'll proceed to something more here: distributed energy intelligence, architecture of key units. This is one key unit which we are talking about, the EIU, Energy Intelligence Unit. The next level, all of them are put together. We are going to have one. This is the form fit function. There are 3 F's which we talk about. Any product will have 3. One is called the form, another is called fit, another is called function. What is fit? Dimensional fit. It is supposed to be of dimensional. And what is not only the dimensional, we are talking about its planarity. We are talking about various aspects with reference to its orthogonal nature, planarity, all the kind of geometrical issues, and then all the kind of things which are necessary. Okay. Do you know one thing? If you have got some extra metal somewhere, that can also be a cause of interference. If you have got a hole somewhere, some between, you have eaten into the metal and you have lost the strength of it. So there are so many aspects of it. That's why I think all of you students, they are learning in mechanical engineering, FEM analysis and all those things, finite element analysis and all those things. Even electrical students must learn. Okay? There is something called FDFL, fault detection, fault location. There is something called BITE, built-in test equipment logistics. So you have to learn all these things. These are all coming into the appreciation of how to build a product. You are all learning how induction motor works. Now, how to design an induction motor, number one. Number two, what factors go into making it and building it. That is also important. Now you are all using the TV, just switching on and doing it and playing with it. But what goes into the TV architecture, how many people know it? If you know it, that will add to your intelligence. In fact, you will use it very optimally. Okay, coming to this point, three form, fit and function. Fit is basically dimensional fit. Form is the technology factor. What technology have you used it? Have you used the microcontrollers? Have you used the FPGA? Have you used what circuits have you used? That is the matter. That is the form. Next, the function. What is the end function? Sometimes it is possible to achieve the same function with a different form factors. Sometimes you can achieve the same function with a different fits. You can have some huge AC. It is also giving a temperature minus 18 degrees or 18 degrees or 20 degrees. You can have a very sleek one which is there, and that also can give you 18 degrees it can maintain. So form, fit and function. The same function can be achieved by different form factors, by different fit factors. So when you are talking about a product, remember there are three things. One is called form, another is called fit, another is called function. Okay? So for the same fit and same function, the form can be different. So in the beginning, we all used to use some microcontrollers and other things, from memory management. We had FPGAs at a later level. I happened to be, by the way, I had the fortune of developing from those days to today. So perhaps every technology that has actually come into the industry, I have tested it first. I have used it in my time. When the FPGAs came, I think I happened to be the first engineer who used the FPGAs field program to get into electronic warfare systems. And I went to Xilinx. Xilinx called me. Xilinx is the one which makes the FPGAs. So I gave a talk to them actually on that. What is the kind of operation? Now I am coming to this form, fit and function. So you are aware of what is the form, what is the fit and what is the function. So when I talk about this feeder level energy intelligence is designed as a 4U 19-inch rack mounted industrial platform. Okay, the next one. I have explained about what goes into the technology design of it. It is in a very fine print, and this can be read, this can be understood, what goes into this. I will explain in a different way. So what is this prototype? We are making a prototype of what? We are making a prototype of one energy intelligence unit, and one in between, one intermediate aggregator unit, and one this rack. The whole thing becomes one set according to me. And if you make that 4U 19-inch rack, that becomes the prototype. And if you can make one prototype after all this work, and if you prove it, then you will be able to hand over to any industrialist who will be able to buy your complete technology. You will be able to buy your technology. How does he buy? He takes the transfer of technology. What is transfer of technology? How is technology transferred? Technology is transferred into two forms. One is the drawings. Product exists in two forms. All of you must understand. Product exists in two forms. One is it's real, physical. Another, it exists in virtual form. That means it's drawings. It's all known. Product exists in its all known, and product exists in physical. So we give him completely the virtual product in terms of its all known, in terms of its design know-how, in terms of its COT. Now I have got two methods to give it to the manufacturer. I will give him a productionized TOT, that means only for the production what he requires, I will give the production although. I will keep the design with me. I will not give it to him because that is my IP, that is my intellectual property. I want money for it. I want royalty for it. I want to be honored for it. So I will give you the production basis on some kind of a license. I am giving you some commercial aspects of it. I want all of you to know it because I want the university to engage into a research institution which will make these TOTs possible to the industrial manufacturers outside. That's why I am giving you this. So I will give you the entire production know-how, and after that, whenever you are selling each unit, I want some money for it. That's called license-based GOT. It's called a form in simple linear equation, A plus BX. What is that? A plus BX. When you say A is the money which I take for giving it to you, and after that for each product which you sell B or X, I want some B. Maybe 0.01% royalty I get it, but it's substantial. It is like the book which you publish. Each book that is sold, then finally the author gets some royalty. It is the same way. It is the same way. So many pharmaceutical laboratories are doing it. So many medical universities are doing it in US and UK. And so many engineering universities are getting money. How do you get money? How this university must run? I want to share with you. Right now, engineering college here is running on some funds, some fees, whatever it is. There is some kind of two kinds of levels of source. One is the fees which students give. Another is the one which you get in terms of funds and other things from the. No, suppose you think one more method that you are able to generate your own income. On one hand, you can say the university heads of the state, don't worry, if you give me fine, if you don't give me also fine. Thank you very much. Maybe with the money I earn on the royalties, I can subsidize to various poor students, and I will tell them, don't pay me the fee, I will take care of you. Do you know that in Stanford University and some places, some students are given completely, they get a card. They get a card. With that card, everything is free for them. And how can they afford that? They can afford that because they make money. How do they make money? By research. So according to me, every professor should be making some kind of research with his own research scholars for the students. That's the idea I'm talking about. So here we are talking about modular, this is the one, okay, let me skip that particular subject, let me go into it. So this is the one which is the representative form. I talked to you already about energy optimization model. So what is the R&D methodology which we have? A systems engineering approach, some key stages. How do you do this design? There is something called, we write what exactly is required. First is, what is your need? That is called requirement. From requirement, we go into specifications. From specifications, we go into design. From design, we go into components. From components, we go into the build. From build, we go into the test level. From test level, we make the proto. From proto, we give it to the commercialization. All of you are clear? First, you tell what you require. Your requirements are written first. Then we will translate requirements into what? Specifications. You may have only, you require some 35 lumens here for the illumination. But only 35 lumens, you will not get some product outside. You have to have specifications. Okay, you have to understand what you require. Suppose if you require, I require some 150 lakhs here, 250 lakhs here, that's what I want for the illumination level. What do you want to go about? What do you want to go about this kind of a scheme? You want about a different kind of a scheme. You can think about it. So first is requirement, next is specifications. From specifications, we go into the design. When we make the design, we make the component structure. That means that is the time we make the bill of material. From the components, then we start building the proto. In between, we get the complete connectable, so we make the proto. Then we test the proto, whether we are able to achieve that kind of need, whatever we have to go back. That is called audit, technical audit. And then when we build proto, we are satisfied with the audit, then we will be able to proceed ahead. Gentlemen, you are talking to a person here, I am here, and I am talking to you. I have done phenomenal this kind of audits in life. I have done for EW systems, I have done for missile technologies, I have done for aerospace, so many gadgets, I have done for many of the industrial requirements. There are so many data acquisition systems, something called SCADA, postgraduate students, the SCADA. You are aware of SCADA? Supervisory control data acquisition systems which we are talking about. On those systems I have done the audit. Even today I am called for an audit. Last year I was called for an audit of a surveillance system, a composite surveillance system, electro-optics based. I did 3 days stay in Bangalore and I gave them some 85 observations to them. So software, hardware put together and all subjects. So we do the audit. When we do the audit, we understand whether we achieve the purpose or not. When the audit goes through, yes, you have achieved the prototype. When you have achieved the prototype, then you have two options with you. You invest, you make the product, you take the money, you sell that particular thing to somebody who can buy it from you. Right? This is the way we go about it. This is called systems engineering approach. We go about the key stages. Exactly whatever I have told you, I have written in this place. This is the methodology. That is, we do a hybrid V and V model. Hybrid V model. What is the V model? V is this, basically. This V is basically we are trying to make all the kind of product specifications and other things. That down below that dash, this is V we are talking about. This is basically building it with reference to system design. This point is the prototype. Then this side V we are talking about is the verification, validation and testing. This is the V model which we talk about. V model is basically we take with reference to building the entire product and then build the prototype and then the testing. In testing it we have got 3 stages. Of course, quality testing is different, particularly with reference to the software. There is no product which is not software driven today. In 1998, we are talking about 1998 to 28 years ago, I was the chairman of the Trishul missile launcher. It was entirely software driven. It was not manual driven. The first missile launcher produced by BHEL at Ronipet for the Trishul missile, which is surface-to-air missile of Integrated Guidance and Development Program of Dr. Abdul Kalam's. I was part of it, and I was the chairman of it. And we did it entirely software operated. I'm talking about 28 years ago. That was the stage. And today you can imagine. So there is no product which hasn't got the embedded software in this, implicit software in this. So you can't say that if there is only computer science engineering, there is a separate branch and I am not going to touch it. No, nothing like that. Please be clear in your life. If you are an electrical engineer or civil engineer, it does not matter for me. If you are not aware of your computer science or computer technologies, and if you do not know, I'm sorry, you are no engineer. That's the stage today. So when we are talking about this testing, there are 2 aspects of it. One is called verification, another is called validation. Have you heard of these 2 words? Any students here? Have you heard of students, please? Postgraduate students in principle. You are my target students today. So, because you are going for higher length. Now, what is verification? What is validation? Permit me, sir. In another 5 minutes, I'll finish first part. And what is verification? What is validation? Anybody? Anybody? Verification is what you verify. Validation is what you validate. Don't explain like this. That interview which is there in one of the YouTubes. So, verification means conformance to specifications and the design. That is verification. You want a grill to a window. So what you have done is you have given a beautiful design, beautiful specifications, and you have given a drawing and you have given it to a fabricator. That chap made a beautiful grill. You wanted aluminum grill? Yes. You wanted aluminum, some MG5, MG6 where the magnesium content is less, etc. Some alloy, he has done, yes. And after that you told him what is the thickness, what is the weight, what is the fit, and what is all those things, etc. On that, yes. You have given a drawing, you have given specifications, material specifications, dimensional specifications, end-use specifications. There are so many specifications. If you are an engineer, you will talk in so many terms. Okay? Specifications is a broad term. So finally, he made the grill. Now you have gone to his workshop. You have got the drawing, you have got everything. You have checked it. You also had an inspector who could check it. Absolutely fine. Absolutely fine. 1 to 1, no complaint. And now the fabricator says, please give me money. You give him 100%. That is, you have given him the full money, 5K check. And now what you have done, you brought the grill. You wanted to put it to the window. It is not fitting properly. There is some clearance, there is no planarity, there is some loose space, there is some kind of, what I mean to say is, there is some backlash here and there, there is some kind of, it's not a tight fit. There is some problem. That means in the field, you are not able to exactly apply and adapt it. So there is a problem. That is validation. Okay? Is the product right? Is verification. Is it a right product? Is a validation. Remember this. That's all. So we are talking about the same thing here when we talk about methodology, characteristics and core objective. So in the hybrid, I was talking to you about this hybrid V. One simple word here you should know. So that V is verification validation. When you say hybrid here, since AI has come into the scene, since you have got AI into the scene, there is a lot of things called interoperability. Interoperability means what? This AC, now you have fitted in this room. Okay, it is working. Can you go and fit it in some other room? Will it work or not? It will work. If you go and fit it in spite of the fact that there are another 4 ACs, maybe if you fit it somewhere else, it will fit or not, it will work. So interoperability means in a kind of harmonize the environment, apart with others, you are able to work with it or not. So very important aspects of it. So this is called hybrid V testing. This particular product which I am talking about, it requires hybrid V and V testing. So we will proceed to the next one. There are 6 milestones here. I will just straight away go to this product. There are 6 milestones here. There are 4 phases. If I happen to be with you as your professor and as an industrial expert guiding a good of competent people, I use the word whom I am not going to teach Ohm's law onwards. I am going to explain from different stage. So if I have such kind of competent 4 or 5, some research associates, I think I will be able to do this project in 1 year time. In that 1 year time, that is, what are the various 6 stages, phase 1, phase 2, phase 3, I have explained here. I have explained here what is phase 1, what is phase 2, architectural freeze, system freeze, and after that going about it and finally checking the prototype in these 6 phases and 6 milestones. 6 milestones spread across 12 months. Each milestone means that is the definite stage you have received. So first milestone stage, you have got the complete requirements completely closer. You know what you want to do. Second, you got the prototype completely. For that, you require complete modules, and you require all the wherewithal. You got the DOM and everything done. The third one is you have done the energy intelligence unit. Like that, I have devised it here. The 6 stages, so 6 milestones, 4 phases. Over a year, we can be able to do this project. That's what is my thought. If you take more time than this, then what happens? There will be somebody else who will be in this. Please understand. You can't eat into the time. As an engineer, you have to have, first of all, as an engineer, you forget your sleep. If I could work at this age, about 14 hours a day, which she knows, she keeps on looking at me. In fact, she tells me at 2 o'clock in the night, please go to sleep. So, I am sharing with you. If I could make some number of reports in the midnight on Saturdays and Sundays non-stop, any people like you should really have 0 time for your entertainment. I use the word, number 1, professionally get obsessed, and after that, give no respite and rest to yourself, pursue the knowledge like a sinking star, as P.V. Shelley says, and achieve things. If you delay, what happens is somebody else will be in your space. Some other company, you think people won't get this kind of ideas? Already my idea has gone into some other world, I am telling you frankly. The only advantage you have is if you possibly do it faster, you will be able to go to the market much faster. Please understand. So you can't delay things, you can't procrastinate things, you can't afford to wait things to go on. That's why I put a hard 12 months time. If I do anything more than that, perhaps we are not required to do it, somebody must have done it already. Please remember this. We have to be fast. We have to be fast at the first time, everywhere and anytime. That's the point. If you are a competent engineer, and if you say, I am an engineer, which I would like to say to myself, then I am first. I am first everywhere, anytime, and fastest also. I would like to have, and if it requires a lot of learning, I would like to spend all my midnights to learn. There is no question of somebody telling me you learn more. The only way somebody can respect you is nobody need to tell you you have to work more, you have to learn more. If somebody has to tell you you better work more, better learn more, that means you have no value. Somebody is trying to tell you. This is the kind of professional pride that you must take. And then you will be able to get into the name word mainstream. So this is what Deck 2, I'll take 5 minutes break, and this deck 2 will not take much time, but any questions after this, I will welcome it. Can you give me one today? Are you happy with this presentation so far? Any questions now? Anybody can ask me questions, no problem. And I will be able to answer most of them. To say all of them, it will be a matter of pride. I don't want to. I would like to say most of them. I would like to. Certainly, I would like to. Deck 2 is not much. It's 10 minutes more. Only 10 minutes left. 10 to 12 minutes. Any questions, please? From students? We'll ask. Can I take 2 minutes? Just 2 minutes. I would. I hope you were able to follow me. You are with me. Oh, if you can help me. Great. Yeah. Anything will do. Any tea-like substance is all right. Yeah, bottle milk is excellent. I have very small requirements in life. Nothing. Anything will do. Can you tell me, sir? I respect your question.
Yeah, you were saying about energy efficient rice and all. And it is the individual is going for the
You got it, sir.
all fine. But unfortunately, the state of Andhra Pradesh, now for farming sector, the energy is free.
Free of cost, sir. But that is a problem which is reflecting on us, sir, with the subsidy. But particularly, the money, see, government is getting. Where is government getting? It is on you. You are paying for it. You are paying more for 1 unit, and you are paying in terms of slabs. If you work, first 50 units, first next 100 units, next 150 units, 200 units. Finally, when you are taking more than 400 units or something like that, you are paying about 8 rupees or 10 rupees or 12 rupees. I used to pay my electricity bill 15,000 rupees, 18,000 rupees, 20,000 rupees like that. Now I have a solar plant in my house. I have my own solar. I got installed capacity of about 5 kilowatt plus. So that also is not sufficient for me because I use phenomenal. That can give me only about some 700 units a month in a seasonal month average. About 750 in summer and about some 600 odd units in slowly then it goes down seasonally. And I'm still paying the bills. So who is paying for it? The farmer is getting it. And now he is a farmer conscious, he is a farmer responsible. Do you know what it is? There are occasions that he has switched on his pump and gone home. And the pump is actually constantly working non-stop. There is no requirement whatsoever. And sometimes it is working and more next day it comes, it is not working at all. And there are bell drives. Do you know in some places there is something called a bell kind of a thing. And there is a drive to bring it water up and give to the irrigation. There is a drip irrigation plants, there are harvesting missions. There are so many of them. If you have got warehouses where he is going to put perishables in cold room and cool room, do you know how long they are running? They are running 24/7. If you talk about perishables, they are running in the warehouses 24/7. Cold room plants. Only don't think about some induction water for his stock only. There are so many industrial drives. And for all that you are paying. And suppose, okay, we will pay for it. But instead of paying 5 rupees, I would like to pay 50 paise. Is it not good? It is good. So therefore, if I know that you are inefficient, I have to account for your inefficiency by my extra efficiency. That is called management of life. It is like wife and husband, simple. Somebody is more efficient, somebody is less efficient, but the family needs to be efficient. You agree with me? So the state needs to be efficient. The state needs to be efficient. Even if farmer is inefficient, we industrialists, researchers, we are scientists, we are engineers, we need to be efficient. So therefore, we are in a position to bear with such kind of pockets of inefficiency, and we ensure that the burden on the common man is less. So therefore, these things are required. Okay, what is Deck 1, Deck 2? In my report, I have made 15 sections. There are 15 annexures. This is 163-page report. I have put double-size print, so therefore it is less work. Otherwise, it is a very big volume, and it can be more actually. I have condensed it. 15 sections I made into 2 parts. One part is section 1 to section 8, that is completely technical. Then section 9 to section 15, that is administrative. Here we need to have some administration. How do you run this project? These people will come and start working as interns or something like that, or project associates. But that is not project. There is requirement of money, there is requirement of people, administration, stock taking, measurement, control, and everything is bound by within 1 year time. You understood? No? When 1 year is 1 year. Your engineering course finishes in 4 years, it has to finish in 4 years. Okay, some students may take 7 years by the backlogs, that's a different issue. But it has to finish. Please remember, breakfast must be at breakfast time, lunch must be at lunch time, dinner must be at dinner time. You can't have today's breakfast and tomorrow's dinner. Will it happen anywhere? It will not happen. Why should it happen in our professional life? And second point, this PAT CPM and all these failed subjects according to me. Your project management. You take various activities, each activity has got some activity time. You synthesize all the activities, you give some relaxation elements, that elements, this elements, and make the project time. That's not the way it's going to work. Think of the girl's father. He is going to give a girl in marriage. And he has fixed up some point. Okay, fine. Now what does he fix up next immediately? It has to be done in Vaisak Masam, it has to be done in Shravana Masam, it can't go into some other thing, Jeshtam, Ashadam, etc. It has to be done. Come what may, it has to happen. And then he will go near the function halls or some venues. And somebody will say, it's not available today, it's not available today. So he will sign up with some person, some dates. So he will come back. I have to do it in June 14th or 15th or 16th. He will fix that particular thing. Then he will print the card. He will give the card. I want to tell all of you, tell me, has any marriage failed to your knowledge which has not happened on the date that was printed on the card? Did it happen? Will it happen? What will be the consequences? If he wants to postpone the date, the hall will not be available. If he wants to do it, something else will not be available. So therefore, there is no option except to complete it on that particular day. Similarly, your valedictory function. It has to happen on that day because some governor is going to come, some chief minister is going to come, somebody is going to come. You understood now? Yeah. Things have to be ready. So therefore, remember in life, how do you do project management? Means fix a date, work for that date. Simple. Do not give excuses. It takes more time. Even the sun has got only some fixed time, moon has fixed time, so you have got only 24 hours. You have to make your 24 hours. Be unkind to yourself if you are going to be a professional engineer. So therefore, I made the complete project report and I put it into these sections. This is not very relevant. This is relevant only for the senior officers who are here, professors who are here, and the project administrators who are going to be. This is relevant for them. So therefore, I am not going to take too much of time. And these are some flexible issues. These are not very fixed issues. So I am going to cover it in a quick time. So transition from the technical foundation to the execution governance. We are talking about the second deck, governance institution. How are you going to govern this project? Financial structuring and control mechanisms, and risk commercialization and strategic impact. risk I want to share with all of you. I have professionalized something called risk analysis. What is risk analysis? What are the various risk factors? What are the factors which are going to lead to the risk factors? And what do risk factors mean? What is risk mitigation, risk minimization, risk cancellation, risk nullification, and how do we go about it? Then something important, if the risk has to happen, how do you quantify the risk? Risk is in terms of time overrun and cost overrun. So what is the effect of it in terms of time length? Is it going to be, instead of 2 months what we planned, is it going to be 4 months or 6 months or 8 months? We have planned it with reference to 1 crore. Is it going to be now 2 crores or 3 crores or 4 crores? These are the ways that politicians are fooling our people. I'm telling you frankly. If you're really getting into this college project or this kind of projects, these are all going on time overruns and cost overruns. Yes or no? So these are the risks. What are the risks? Risk is in terms of time lost, additional time. Cost is in terms of the additional money which you are going to pay. And each additional rupee which you are going to pay is a wasteful element, because it could have been done without that additional cost. Have you done in time? Have you done earlier in time? There was no requirement for you to spend that much more. So what are these risks? So this risk analysis is a very big subject, right? And I am called as a risk analyst of major projects, and I have done in American format the risk analysis of the major issues I have submitted. So the risk analysis itself, it can be a good thesis for a major project. I just want to share with you. So we are talking about risk commercialization and the strategic impact. So this is basically administrative cover, financial cover, which we are talking about in Tech 2. It's okay. Rule framework. I said it's a multi-layered framework. What is here, I will explain to you. Otherwise, you can go here. There is an academic institution. I require research. Everything I cannot do myself. I may be an industry expert, but I require lots of people. And what is the idea? The idea is not that it is always we. Please understand that. It is we need to do it. We are a team. I have developed so many people. So therefore, it's an institutional, academic institution. But academic institution requires a lot of support, industrial support. So therefore, I will be there. There is a governance structure. So this is actually an integrated, a kind of a framework. So therefore, there is one academic body, there is one industrial body. Our industrial consulting body, I said I am myself. That is Prasad Consulting. Academic body, it is JNTU. That's what I said. Okay, we'll proceed. Role of JNTU. What is the JNTU role? Have all of you have some kind of a place here, have some kind of good professor associates, and I come and explain what all to be done and tell them what are the various sections which have been gone through. They go through, they deal with me, they talk to me, and they develop the product. And after that, we test it, we go about it, and together, first of all, both of us, we are going to go evaluate it ourselves, field test it, check it is working, not working, what is the fall factor, what is the deficiency. So this entire role of academically building it completely, and only responsible administrative factors for it, for your conveyance, for your requirement, for your expenditure, for your academic bill, for your kind of bill of material which you require, for prototype, for various things which are required. That's all going to be institutional. In my area, that is which is supposed to means anybody for that matter, not me alone, an industrial body which is going to help you. That industrial body is supposed to give you all industry factors, explain to you how to go about it, various industrial aspects of it, and participate in the preliminary design review, critical design review. And if you are using AI reviews, you know that AI has got some standards. You know that IEEE standards are there for software 1007, IEEE 1007. There are so many build standards, there are so many configuration build standards, there are so many vibration and shock standards which are supposed to be J suspender 5, joint service specifications 5555, they are relevant for the industry. There is something called electromagnetic interference and electromagnetic compatibility. You take this AI module and go and put it in some place, it has got electromagnetic interference. It will not work. So there is something called EMI, EMC. There are standards for it. The standards 461E, 461F, etc. So all these standards I will explain from the industry, which because the institute may not be familiar, so build them to that particular level and help them in building the product and validation of the product, testing of the product. And also, I am a CSA, Certified Information Systems Auditor. So you make so much of documentation, software requirement specification, system segment specification, software design description, interface design description, and version controls, software test reports, software test plans, AI control test plans, use cases, all these things. The industry man has to work with you. So that is industry's participation. So there are two, they have to work together. I have explained this already. Academic core team structure. According to the DPR, what you require is principal investigator, co-principal investigator. You have a principal investigator who is a professor, co-principal, associate professors, assistant professors, depending upon what your thing is permitted. You are talking about administrative head or principal or vice chancellor. The money is more. You can't be on the, see, there is an institutional hierarchy. We call it as a competent financial authority. What is that? Competent financial authorities. If it is 10 rupees, the madam can give. If it is 100 rupees, it has to go to the husband. So that fellow has to come here. And if it is more than that, he will go to his father. If it is much more than that, both of them will go to her father. So there is some kind of a method that we go by hierarchy. So therefore, it is a competent financial authority. So you have got some powers at the professor's level, at the principal's level, at the vice chancellor's level, perhaps at the other granting body or another body where you are going to get the money from. Suppose if you are already booked with some kind of a commercial manufacturer, suppose if you have got NTPC or somebody, Andhra Pradesh Transco, AP Transco or some Southern Power India Distribution Limited or something that they have already agreed to buy your product, depending upon your credibility. Oh, JNTU, fine. Oh, Commander Prasad, fine. So they've got some kind of credibility. They will say, don't worry, we will fund you, no problem. What is 80 lakhs? Take it, because the money is going to be more. So if they have got come forward, then they also will be on the board. They also will be on the board. So therefore, there is a technical project steering committee that will be there. The technical project steering committee will have different heads to monitor all this. These people who are working now, they are not concerned about it. And you will continue to say like a child, I want ice cream, I want ice cream. So I want this particular module, I want this particular component, I want this, I want this. For him it doesn't matter who is sanctioning it. But for others, it is required to go. I want to share with you, I used to work in EW designs. As a EW head, I was the integrated project head for the various EW designs for Army as well as for Navy. There is something called, those who are electronic students, they will be able to appreciate. There is something called RF to digital. What is a kind of system? First up, there is some kind of a microwave RF radiation that is incident on the antenna, and that is basically RF into the video into the digital we play with it. After that we extract the target information, we take a thread file, we give it to the display. From the system processor, we give it to the display processor. We use a GUI, we put lots of screens and other things, and we make a beautiful acquisition system. So I'm talking about that RF to digital, RF to video, that used to be, basically it's nothing but detect for some real other things, that used to be a super component, RF super component, RF to video, RF to digital. One component used to cost, when I'm talking about 2001, 2002, one component will be 8.5 lakhs. And that is so simple, such a simple component. Everybody cannot authorize it. Engineer couldn't care with the value of it. Engineer wants it for his work. But somebody has to take the accountability for it. Suppose if it is DC offset has gone, modularity has gone, some other component feature has gone, it has to go for some kind of repair or some kind of replacement. What is the cost of it? Lakhs. Whose head has to roll? Somebody in between. So therefore, the organizational governance structure is very important in any project. Okay? Actually, in defense and other places, we have got 3-level structure. We got one is called a normal platform program level structure. We got an executive structure. We got an apex structure. If you got scientific advisor, Union Minister of Defense, Defense Secretary, and all, apex structure. And you got the users like very senior user, Chief of the Naval Staff and the Vice Chief of the Naval Staff and some other people and the directors of the laboratories and all. They are all in the executive structure. And the program management committee is different with scientists and engineers and all. So they are. So I worked in some executive committees and I used to be a visitor speaker for the apex committees. I worked with Dr. Manoj Parikar, he is Technology Advisory Council when he was in Defense Minister. And I'm very proud to share with all of you. I traveled with Pranab Mukherjee, Dr. Pranab Mukherjee, the then Defense Minister in 2006, who became subsequently the President of India, who is no more today. And with him, I traveled. In his delegation, I was there. And he used to treat me like this. That's the biggest thing that I have got in my life. And phenomenally intelligent person. I used to work. Okay, so therefore we have got a kind of structure like this. This is the technical project committee. We have got Apex Technical Governance Authority, that means people who sanction money, who give money, etc. And the composition of the committee is the Vice Chancellor JNTU, depending upon the funds. This particular project I rated it about 80 lakhs. This project I rated it about 80 lakhs for the entire thing in 1 year completely. 80 lakhs appears to be too much of money for you, but when I tell you it will be not significant money. 80 lakhs, any company will be in a position to be. Even a startup is prepared to get you on some kind of a sanctions 80 lakhs these days. And there is something called the banks, union banks, the public sector banks, they are able to give, there is something called CMA for your information. There is something called credit monitoring assessment. If you have something called the CMA very well, and if you have CRISIL very well, they are able to fund you much more. Today, after Modi has come, the things have phenomenally changed, particularly in the defense and aerospace. Funding has not become a big issue. A small company yesterday had got about some 30 crores funding. It's not a big issue. So, but I concisely put it about because I limited up to only prototype, so therefore I put it about 80 lakhs. So, key responsibilities functions we said. This is the kind of a chart which I gave you. We got the chair on the top and the co-chairs and some kind of a committee constitution. Basically, whatever I have explained you is the committee technical project steering committee. You can go through the slides afterwards. Governance, the multi-tier governance framework I mentioned to you, different stages and defined grounds, the level 1 academic level, level 2 a project level, level 3 at the project steering committee level, level 4 at the grants commission level, like that we can have different levels. And escalation pathways, you want something, you are not happy, he goes to someone, he goes to escalation pathways. Suppose you want some major item which has to be imported for some reason, not in this particular project. I mentioned to you, you go by escalation. He explains to you, he explains to you, he explains to you, so therefore there is a pathway for escalation of the requirement and trying to get it. Not in this project. This project is relatively very simple according to me, very simple project. Industry, academia, coordination. I have already explained to you substantially what this is about. It is all English, so it is all put in the same kind of language, it's the same line in different bottle. Review and reporting mechanism is very important. We have formal review, reporting structure, review cadence, basically reporting formats, validation process, and we are talking about core objectives. There is a method that will go in. There's something called different kinds of methods. DS150 methods of warfare electronics and all, they have a documentation system in that. There's some network diagrams. You go by analysis. And somebody asks you, present the project. You are not going to come and start some kind of Bhagavad Gita sloka. You are going to tell very clearly, this is the project. I am here. This is 80% ready. This module, 70% ready. This module, this is ready. This requires this much for you to give it 100% ready. This will complete by so-and-so. This will complete by so-and-so. Everything has to be talked in terms of time and date, percentages, components. Everything has to be talked in finite values. If you cannot give metrics to your progress, it is no progress. How much have you done? Oh, I have done a lot of it. That is not the progress. I have done this much. It requires further this much for it to complete. These are the metrics. So any definite follow-up, any kind of program coordination has to be in finite metrics. The finite metrics are going to be decided on this. I'm giving the gist of it. There are different layers of oversight, means monitoring of it completely. These are the deliverables which we are talking about. everything is finally deliverable. The father who is educating you as a student, when you go through, he pays the fees and he helps you, he looks after you. Finally, there is a deliverable. Please remember, you are auditable for the deliverable. The professor who is paid, he is coming and teaching the students, there is a deliverable from him. There is a principal who is looking after this entire organization, there is a deliverable from him. Everyone is finally a delivery manager. Everyone at the end of life, you are delivering something or the other for your family, for your own ecosystem, for your own professional position, public position. You are delivering. What do you deliver? What exactly are you called upon to deliver? In how much time? How? In what way? How do you measure it? This is what is life. This is called the audit. So the deliverables are very important. We are talking about structured and certifiable output framework. Deliverable categories are you deliverable at module and you try to check, and documentation. There are documentation deliverables, there are product deliverables, there are testing deliverables. What types of testing are available? Anybody here? You've got the black box testing, white box testing, regression testing. After that, there is something called moving testing. And then you've got CPCI testing, DO 178D standards. You want to know what is testing? You read the standards called DO 178 for the aerospace. And you come to know what is exactly the testing. And in testing also, there are methods. There is functional testing and there is a sneak testing. What is functional testing? You are trying to check. I want 1, 2, 3, 4, 5, 6 functions to be executed by this software. Is my software executing this 1 to 6? Yes. So functional testing, yes. But is it acceptable? No. There is some other testing. We are always looking at what it is intended to do. We are not looking at, is it doing something which it is not intended to do? It is not intended to do something. It is not supposed to do something. Is it doing that? That is called sneak. What is that word? Sneak. There is something called sneak circuit analysis. When you put all components together, they may do what you want, but they are also doing what you do not want. Please understand this. So sneak analysis testing is also very important. So different levels of testing, gentlemen. Okay? So you do all these deliverables. So deliverables are documentation deliverables, the product deliverables, and after that certification deliverables. At the end of it, when you say that you have passed out, what is the proof of it? There is some certificate. Somebody has said that you have passed out, this is what is certificate for you. You can't go and say, no, I studied in engineering college for 4 years, so therefore I am an engineer. You may be an engineer, but show me your certificate. This is what is certificate. Oh, you got only second class, please go to the last bench, we are not requiring you. You got first rank, okay, please stand there, we will see. So that's the way you go about. Okay, next. Technical documentation deliverables. What are the various documents which you give? In software, if you talk about those who are, it's important. There are 9 types of, fundamentally, there are 9 types of documents. One is called system segment specification, that is major. The second one is important. Now onwards you started. SRS, software requirement specification. IRS, interface requirement specification. Next, VDD, that is version description. Software description, interface description. Software test reports, software test plans. That means user manual, software user manual, firmware user manual. These are the various types of verification validation reports. So these are the various documentation. If you talk about the hardware, which is also mixed actually, then you have user manual, technical manual, installation and exploitation manual. There are so many. So you can't give him this product, take this product and go. How is he going to use this product? Suppose you buy an item, a TV, you want a manual along with it or not? And suppose that the shop fellow says, you take the TV, I'll give you the manual after 1 month. Will you accept it? No. Documentation deliverable has to be along with the product deliverable. You understand now? So this is what we are talking about. In case of AI, it has become very complex. AI has got standards. There are some AI deliverables. AI has got to be checked very substantially. AI testing is not being taught in colleges here. It has started only in foreign colleges now. I don't think even IITs are teaching even today how AI levels are being tested. There are methods, there are some certification standards, there are definite standards by which AI modules are tested. Okay? And but substantial testing alone, all your products come out to your ChatGPT and other things, those things will come out with substantial testing. Okay, AI validation. Financial structure view, 80 lakhs. I have basically I have given a view. You can have a look at it, sir. I am skipping it for the students. This is about various. I have taken about some 5, 6 levels, 7 levels. I have plotted how much for each. I have taken time and time and time to make all these things, and I am skipping it because I am giving digitally. I am giving all these things to you. One hard copy I am giving, and you can use digitally. I will send it across. Kindly go through it in your own time. Financial governance model I have already mentioned to you how we do it. Cost benefiting, investment versus savings. Now here I would like to go about basic, very good. Put it on the hyperlink and take it out, please. You see the green one, no?
Yeah.
Yeah, press the hyperlink and be there only to help me.
Hyperlink.
Press it.
Yeah, I pressed it. It's opening here, but it's not opening there.
It's opening there.
Yeah, it's opening here, but it's not opening there.
Okay, leave it. Don't worry. We'll circulate it afterwards. It's not opening here.
No,
The
it's
PDF
not.
doesn't open here. I'm surprised.
Yeah, I have to close the presentation. Before I come.
Do one thing. One second. Just don't bother. Wait. She is quite competent to handle it. You close this. No, minimize this presentation first. Minimize it. Escape. Minimize. Go to the same folder in which you take the investment or something like that cost I have written. 2 files are there. One is financial one. There is one more.
Financial pages DPR.
Next one.
Detailed project report AI driven energy optional
Energy optimization. Yes. Take that PDF. It's not coming. That's important for you because you don't understand what is the importance of so much I thought. The energy optimization PDF.
No, that's not casting.
That's a PDF baby.
It's not able to cast.
Okay, fine, leave it. Okay, I have taken like this. I have taken about 20% optimization on various factors. I'll give you my thumb rules. I have taken about some 200 odd field units. I have calculated. I will give you that paper, you can go through it. I would have explained it, you would have enjoyed that explanation, but I am unable to project it here. Come, it's all right, leave it. I am talking about 21 lakhs per feeder. 21 lakhs per feeder I am talking about, and I have calculated about 200 odd feeders, which is about 4x, 5x multiplication factor in revenue saving. 200 feeders I have worked out the cost. It is coming to 42 crores. If I take the state span, and if I take even half the state, a few districts, about some 8, 10, it is coming to about some 420 crores I am talking about. Roughly I am able to manage the subsidy. I am able to manage a huge subsidy. And now I will tell you, suppose if I take this money and give it to you, government can do more projects. My recommendation to the state happened to be, I worked with Sri Chandrababu Naidu in 2003 and all. In fact, I am writing to the state that any kind of energy optimization project, the money realized must go to the universities. We should, high time we start thinking universities are pockets of excellence. It is the universities where we are rolling out engineers, we are rolling out professionals. It is the universities which have got the maximum number of PhDs here as the professors. It is the universities who have got the phenomenal manpower is available in the only universities. Each professor is rich in terms of so many students with him. In which industry you will get 1:4 or 1:5, one team lead and 5 engineers or 6 engineers working. You won't get. Professors here, one professor may have 10 students, 15 students. You know, in Stanford, Harvard, Agrarian, etc., each professor has got a wonderful team. All his proceedings, whether you take IEEE, whether you take higher level papers, they are all written by his student scholars. They put the professor's name only for the recognition of it. Actually, they do wonderful. My own son who did his MS from the Purdue University, and he happened to be one of the student scholars in fact. He was facilitating his professor working in a big project actually, to be very frank. So it is, if at all we have phenomenal academic research capable potential, it is in the universities. If the universities recognize it, they will be able to make phenomenal products. Why depend on only DRDO? Why depend upon only some laboratories or CRM, etc. like that? The universities themselves can make. Then you can ask me one question: do we have time? Do we have time to give all the curriculum and teach students and also work with them? Then it will call for some different kind of model of working. In foreign universities, they don't teach each and everything. Please remember, professor is a professor, teacher is a teacher. Teacher is different. Upadhyayu is different from Adhyapakaru. Adhyapakaru is different from Shastraveda. Please understand. A teacher is different from lecturer, lecturer is different from professor, professor is different from a research associate is different from someone else. So there are different levels. You are, at an MTech level, I am not going to teach you everything. It will be stupid to teach you everything on the classroom, on the blackboard, or OHP, or some kind of PowerPoint. I will tell you this is the subject, you go prepare for it, come back and ask me if you have got any doubt. And I will take a test for you. You have to prepare yourself. You have to learn yourself. I am telling you frankly. We also used to enjoy in our classrooms. But at the examination time, we used to sit with it and we used to manage ourselves. In fact, there are so many circumstances we never remembered whether the professor taught or not. But we were trying to learn it from the fundamentals. And then we came and put it much better. So, what I meant to say is you have to teach yourself. Professors will make time. Saturdays, Sundays, semesters. Now, hostel is closed because of some vacation. Use it for your research. So that's how we have to go about it. So my recommendation to the government is to give all this kind of savings to universities. And so we are talking about some 420 crore. I have got a workout, how I worked out 420 crore, how the complete thing is. It's about some 3 pages and that I wanted to show, but it doesn't matter. You can always see it. What is this? We did some miracle. So, go to the quick slide, next slide. Given by pressing it, you go. Yeah, manually go. That is the next one. That's one. Go to intellectual framework. Yeah. So there is an intellectual property associated with it. Because we are doing a lot of research and other things, it cannot be given away to company. So there is, it comes. So intellectual property. So how do we handle this idea between the university and between the consulting firm? We can handle the intellectual property. So if you are giving it to some commercial company, then we have to have a royalty for it. We have to have one-time non-cash for it, etc. Do you know how much is charged actually? Approximately for each project, people charge 2 crores, 3 crores kind of money. In terms of dollars, it used to be much bigger, $50,000 and $100,000 or something like that, $1 million and things like $2 million. So that's how the projects are sold. Make some projects, make some good money for your own professional institution. Don't depend on somebody to give you money. You can make your own money. I want to tell you, it's a government college, you can still make it. Next. Commercialization strategy, A plus BX. There are so many other components in which you can handle it with IP, with your commercial partner. With royalty, without royalty, one-time money. There are so many methods, negotiation, depending upon what is feasible for you. I happen to be, what I mean to say, system analyst, and I happen to be in due diligence for various mergers, acquisitions, and assessments of various properties in fact. By the way, I also did my financial management from IIM Bangalore. I did my strategic finance management from IIM Bangalore. So you have to be financial person also. You can't say that I'm only engineer. You have to know everything, my dear friends. Next, the risk assessment I already mentioned to you. Various risk mitigation factors. Policy alignment and state level integration. Once you have this complete thing, you have to go across the state, how to use it across the state integration. And it comes to the policy alignment, it goes to the state corporate bodies. You know that the state has got its own cabinet committee, it has got its own cabinet technical committees, it has got advisory committees. Different committees are there in different parallels basically. It has to go into the policy alignment and it has to be done like that. There are various committees. I used to be in the equipment policy committees for the Navy, naval equipment policy committees, induction committees, various policy standardization committees. I was in Defense Export Policy Committee with, in the Ministry of Defense. So like that, you have to go through various policy level committees to work with the state. And that's the closures, right? So if you do alignment with national state policy, so what you do must be useful to the nation. Please remember, each one of us is here as a contributing person to this nation. We all have a purpose. Remember, we are born for a purpose. We have to have a purpose. We have a goal. Our goal is not to entertain ourselves and sleep and go away. There is something called Maslow's hierarchy of needs. First is physiological needs, roti, kapda, makan. The second level is security needs. The third one is social needs. Fourth level is esteem needs. Yes, I am something, I must do something, I must have recognition, I have purposely, I have doctorate, all esteem needs. There is some other level that is called self-actualization needs. Where the great people like Mahatma Gandhi and other people are. What am I? What am I for? What should I do? Why am I born for? What is my purpose? What is my goal? You all go back before you sleep, ask yourself, why are you first of all required on this earth? Just to pass time and waste time? Or are you born with some kind of a purpose? If this purpose is to light up something for the nation, to contribute something to the nation, why not I do it? And if I have to contribute to the nation, how do I do it? If I am an engineer, I can only do in an engineering manner, in a professional manner. If I am a scientist, I will do in scientific way. If I am a doctor, I will do in a medical way. Likewise, what you should do, aim that and stop working. Align yourself. Then you will go for what Modi is saying. What is he saying? Atmanirbharta. And the Panchamrit, that Panchamrit, you are aware, that particular policy, energy emission policy, zero policy, you know that? That Panchamrit. Are you aware of Modi's Panchamrit? Panchamrit only Puja has a picture given. Panchamrit is a policy where we are talking about energy emissions and things like that. If I have 5 areas, by about another 20 years, we have to have zero emissions, in fact, zero emission wastage. That's the way. It's a beautiful policy. So there are so many national policies. What are you trying to contribute? So this project is one such project where you would like to contribute if you are an engineer. Thank you very much. I finished. I finished. I can go back to the previous slide and say strategic outcomes, way forward and all. This is all very fine. And this is for an MBA student, but for engineering student it's fine. So this initiative defines the next paradigm of our agrarian infrastructure. We are not talking about giving energy, we are talking about optimizing the energy. And there are better methods to do it. There are AI-driven smart assessments to do it. We can do very well. And you are all capable of doing it. And it can be done in this campus, according to me. Thank you very much. Ask questions, please. Thank you. My presentation copies will be with the professor and with others, please.